Morning, Bagunara to everyone. Namaste, namaste. How are you doing? Morning, good morning, good morning, good morning, good morning. Good morning. Hello, hello, hello. Good morning, everyone. Good morning, good morning, good morning, good morning, good morning. Namaste, namaste. Okay. How are you doing? Everyone? Fine? Yesterday you were having exam? How was the exam? How was the exam, beta? Nice, nice. Very good, very good, very good. Paper was little bit moderate. Physics was tough. Yes, beta. It looks. I have told you, examiner can ask question in any manner. You have studied all the things. You have to apply that application. That is more important. How you are applying that applications, right? So, and one more thing, I think you have not practiced. Right now, you don't have your material. No problem. When you will come here, we will give you material. From there, you will practice a lot of question. So that is why, sir, in question P plus Q, our perpendicular is also right now. Resultants, I don't know which question you are asking right now. Okay, okay, okay. When college will open, sir? Beta, even I also don't know. I have already told you. Might be in the last week of. When will the school give books, sir? When you will come here, na beta? Not we will dispatch to your home. We'll give it to you when you will come here, right? So, in vectors, it is a very big chapter actually. But for NEET student, we don't require too much. We don't require too much. So that is why sometimes student can feel that vector is a somewhere portion, right? You know the basic, you know each and everything, but you are not able to solve because mathematics is not required. Right now we are just teaching you which is actually required in the we can say that in the main physics, and main physics will come when you will come here, right? So then your main physics will start. So last week I have taught you guys vectors and that has completed. Not to completely completed, but the rest of the portion when you will come here will again start from the basic and again will teach that thing. So don't worry about that. Today we will have a taste of differentiation. Calculus we will start, right? So today we are going to start. The topic name is differentiation. So this week topic is differentiation and integration, right? And let me tell you guys, it is purely formula based. The most easy thing personally, I believe, if you know the formula, directly apply that, you're gonna get very good, command on this topic if you focus on the basics, right? So let's start without wasting time. And the topic is also very interesting. The topic name is differentiation. Today we are going to start with the topic name is differentiation. So from its name itself, it is clear. In a differentiation, like differentiation is saying to differentiate from someone, right? To differentiate from someone, like every human being having their own personality, like we are differentiated from others. In similar manner, if I want to differentiate, what do I want to differentiate? I want to do some comparison. So to draw a comparison, I have to I have to write a formula so that I can apply on different objects to compare those phenomena, right? Okay, differentiation. Let's see. I'll tell you the examples, right? So, in a differentiation, the very first thing that I'm going to write the formula, let's say a symbol, right? Then I'll explain it with the help of an example, right? With the help of an example. So in a differentiation, the formula that we are having, which we write here, is basically something like this. I'll tell you when very simple example that what this differentiation tells. So for example, if you are having this formula for a differentiation, I'm just writing what it is, d upon dx, and this is y. And how we can write this formula, I will tell you. So don't worry what this is representing. So I'll go to the another slide to explain it with the help of an example, what it is saying. Now the symbol here, beta, I have used this symbol. What is the symbol? D upon dx. This d upon dx. For this symbol, we call it differential operator. We call this differential operator. We call this as a differential operator. Differential operator. Right? And for this y we are having, this is the symbol of differentiation. In that, this y we are having is a dependent function, we can say, or a dependent variable. I'm writing here function. What all these terms I will explain one by one. First, I'm just saying it. X, this is independent variable. Independent variable, right? And about this dy upon dx, we call it as with some name. For this dy upon dx, we call it with some name. So it's our choice what we can say, that if somebody has written dy upon dx, you can pronounce it with this formula. You can say it differentiation of, you can call it as differentiation of y with respect to x. Beta, this WRT means with respect to. WRT means with respect to x. Or there is another name you can call it. There is another name with which you can call this particular function, dy upon dx. There is another name with which you can write this dy upon dx, and that is rate of change of y. You can call this rate of change of y with respect to x. Rate of change of y with respect to x. Now somebody will call, sir, what is this meaning, rate of change? I don't know whether you have studied this term. Now I am going to explain this dy upon dx with the help of this particular line I have written, rate of change of y with respect to x, by taking some examples. So till so far, I hope you have seen that what is the formula of differentiation and how we are going to explain it. So how I am going to explain it with the help of one example. For example, listening. What is the meaning of this dy upon dx? For simple understanding, I will write it in a very simple manner. I'll give you one example. Let's say you are having two cars. Both are starting from same point, right? One is car A, one is car B. Now you want to compare, beta, these two cars. You want to compare these two cars. How will you compare the cars? Now you want to compare these two cars on the basis of what you can compare. So many bases we are having: color, price, specifications, but we are not going to do comparison on that basis. We are going to do the comparison on the basis of their how fast they are traveling, right? So for that, if I give you one information that car A is covering, let's say, 100 meter in 2 seconds. Car A is covering 100 meter in 2 seconds, and let's say the same car B 100 meter is covering in 4 seconds. So how will you compare? Very simple. So here now you will see the car A is changing its position 100 meter in 2 seconds. Here it is changing 100 meter in 4 seconds. So you will do what you will do. You will do some change. Let's say here x was 0. Here they were at the 0 point, origin. Both are at same point, and they have reached at what point? X is equal to 100. They have reached at a point x is equal to 100. So now if you want to do the comparison between, they have traveled same distance, but the time is different. So how will you do the comparison? You will do very simple thing like this: x final minus x initial upon t final minus t initial. X final, it was at 100 minus 0 divided by, here time was 0 when started, and what is the time here, beta? The time here is 2 seconds. So you can simply say 2 minus 0. This is the rate of change. I can denote this symbol x final minus x initial. I can write the symbol delta x. Delta x means change divided by change in time, delta t. So this is known as rate of, whenever rate of change, how fastly x is changing with respect to x. How fastly, beta, your x is changing with respect to t. How fastly your x is changing with respect to t. That is known as your rate of change. So what can I call this? Rate of change of x with respect to whom? T. And in your 10th class, you call it as a speed. You call it as a speed. So speed of your A object will become 50. Right? And what about the V? Similar kind of formula. X final minus x initial upon t final minus t initial is equal to 100 minus 0 divided by what? 4 minus 0. You are getting this time what answer? 25. And this is the rate of which object? This is the rate of B car, and this is the rate of which car? A car. This is the way of representing the rate. It is just an example. There could be so many rates. But if somebody is writing in this symbol delta x by delta t, so it means who is changing here? X is changing. Delta symbol means change. With respect to whom it is changing, beta? With respect to time. So this is your dependent variable, and this is your independent variable. X is depending upon time, right? So what is happening? So if I want to do the comparison between A and B, for that I will see how fastly they are changing their position. So it means in 1 second how much it is changing its position? 50 meter, and it is changing 25 meter. So I can do the comparison now. Which car is moving fast? A. Right? So this is how we are going to use it in the differentiation. Now if you will see here, beta, if you will see here, this change I have written, this symbol and the symbol that I have taught you, it is not matching. Just forget about y and x. Here I have written small d and small d, but here I have written some this symbol. This symbol could be new for you, but let me tell you guys, this symbol means change. This symbol means change. Final minus initial. It could be anything. It could be pressure, it could be temperature, it could be here temperature also. Any function you can use. So many physical quantities in physics we are having, like temperature. For example, if somebody want to measure my temperature with the time, if I'm getting fever, so what will I do? I will check with the time my temperature. So we will call that, what symbol we will use for that? Delta T by small t. So what is the name for it I can give? Temperature is changing with respect to whom? Time. So I will call it as rate of change of temperature with respect to time. Right? Okay. Beta, everyone understood? Give me thumbs up if you guys understood this, what I have said. Did you guys understood the basic? Very good, very good, very good, very good. Now beta, symbol this delta I am using for big change. This delta symbol that I'm using, this is for big change. If I want to use it for small change, at every interval, if I want to use similar kind of formula, so then your this formula that I just written beta, delta x and delta t. This is for big changes. This is for big changes. If I want to write the same formula for small changes, if I want to make it small, for small changes, what do I have to do? I have to replace this delta symbol by small d, and here also small d, and this is your differentiation of x with respect to t. Or you can also say that this is the rate of change of x with respect to t. Is it okay? So that is why this is the practical application of differentiation we are going to apply. It means how fastly the things are changing. How fastly the things are changing. So we are going to utilize this differentiation in our real life problems, right? For example, this is the rod. In this rod, if I keep it inside the some hot water, what will happen? The heat will start flowing. Now, how fast the heat is flowing through it, that is our, interested area where we will try to focus. So that is why now I think everyone understood what is the meaning of this symbol. This is the differential operator. One is y, one is x. So y is a dependent function. Y is depending on x. Like I have told you the previous in this example. Here, what was the symbol you were having? X and t. It could be this symbol also. Delta t by small delta t. So this is temperature and time. Y and x can have any value. Y and x can have beta any value. Right? So I hope basic representation and understanding everyone got, that what is the importance, what is your differentiation dy upon dx. First, everyone should know its name, that differentiation, how I pronounce it, to whom I am differentiating. I am differentiating y with respect to x. First name, differentiation of y with respect to x. And the second one, rate of change of y with respect to x. This is and y will always depend on x. And the example I have told you. Now after this beta, we are going to write some formulas, right? On the behalf of bit, so many questions will come, and this differentiation going to help you a lot when we will study. So I'm going to write some formulas of what? differentiation. Formula of differentiation of differentiation. So the very first formula of differentiation and the most commonly used, right? First, this is your differential operator. Now in the bracket there will be some function. There will be some function I have to write. So I am writing the function is x power n. This is actually your y. So here y is equal to x power n. See, I have told you this is dependent variable. On whom it is depending? X. On whom it is depending, beta? It is depending upon x. So this is known as your dependent variable. This is known as independent variable. What is the value of y I have chosen here? Y value I have chosen here x power n. Right? So here this formula you have to remember. Everyone, you have to remember this formula. In this formula, everyone, this formula going to use so many times. So very simple trick I am going to tell you. What is happening when this kind of question is coming? Here x power n. So power will come to the forward. If differentiation of x power n I am doing with respect to x, then power will come forward. Power came forward. Okay, sir. Then what next? Then next, I have to do x power. Remember this thing again. To the x power, I have to subtract 1 from here. Very simple. What do I have to do? Subtract 1 from here. This is the differentiation of x raised to the power n. Again, I am telling, if something like this come, x power n, you have to push this n to the front, and from the power you have to subtract 1. This is the differentiation of x power n. I hope this is clear to everyone. Very good. Now next, on this basis, I will ask very simple question from you. Let's see whether you guys are able to answer or not. So d upon dx x square. Tell me, beta, everyone in the chat box, tell me what is the differentiation of this. See the comparison and tell me the answer. Tell me answer, everyone. What will be the answer of this? Tell me the answer of this, everyone, fast. In the power it is 2. If it is not visible, it is 2. Again I am writing it is x square. X square. Very good, very good, very good. So many members are answering 2x. It means you understood the formula. So what do I have to do, beta? I have to throw the power to the front. Okay, sir, done. Next step, x. And what was the original power? 2. From that, how much I have to subtract? 1. So what is the answer I will get? 2x. Very good. Is it okay to everyone? It is clear? Very good. A majority member are answering correctly. So it means answer is correct. 2 minus 1, 1. So that is why power of x is 1. And if power is 1, we don't mention, sir, like this, power is 1. Right? Okay, fine. Now next you will be having, okay, one more question I will ask from here. Tell me, differentiation d upon dx of x power 5. This is to very easy. A repetitive kind of thing is coming, so you can answer it. Tell me answer, x power 5. Five into 5x power 4. Some is saying 5x, 5x, 5, 4, 5, 4, 5x power 4. Very good. So beta, what is going to happen here? If beta, what is the purpose of this? Somebody can ask, sir, where this will go? After differentiation, where this will go? Beta, this is the symbol. This is the symbol which is changing x power 5. Here, if This is your differential operator, which is changing your x square. This differential operator is responsible to change this x square into 2x. So that is why there is no need to write it again here. This change has happened in the x square just because of this operator. So in the final answer, you need not to write the operator again, right? Okay. I hope it is clear to everyone. Now the differentiation of x power 5 will be, again what will happen to the 5 beta? 5 will come forward into x power 5 minus 1. So answer will comes out to be what? Answer will comes out to be 5x power 4. This is the answer. To everyone, this formula is clear. Give me thumbs up based on this easy things you have done. Is it okay or not okay? Shall I ask one more? Based on this formula, are you guys ready? Very good. So beta, tell me the differentiation of this. D upon dx raised to the power x power 3 by 2. Tell me the answer of this. Everyone fast. Everyone tell me the answer of this. D upon dx x power 3 by 2. What will be the answer of this segment? This. What will happen? This time power is 3 by 2. This time power is 3 by 2. Very good. 3 by 2 x power 1 by 2. 3 by 2 x power 1 by 2. Very good. Very good. 3 by 2 x power 1 by 2. Very good. Very good. So what's going to happen here, beta? You have to push this 3 by 2 in the forward. So you have to push 3 by 2 in the forward. So when you will do that, from this x, what will happen? From the power, how much you have to subtract? 3 by 2 minus 1. What is the answer you will get? You will get 3 by 2 x, and if you subtract this 3 by 2 minus 1, 3 by 2 minus 1, you will get 3 cross multiply, this will become 3 minus 2, that will be 1 divided by 2, right? So x power 1 by 2, or I can also write it, or x power 1 by 2 means beta what? It means root. I hope you have studied this. So this will be 3 by 2, 3 by 2, this will become 3 by 2 root of x. This will be the answer. Anything can be the answer. Either 3 by 2 x power 1 by 2 or 3 by 2 root x. If power is 1 by 2, its meaning is root x. For everyone it is clear. Very good. Shall I ask one more? Are you guys enjoying doing the questions? Yes or no? Very good. So d of dx, and here now tell me the answer of this beta. Root x. Tell me the differentiation of this. Differentiation of d by dx of root x. Tell me its answer. Tell me its answer. Very good. Very good, everyone. You guys are understanding and telling the answer. Very good. Very good. What is the meaning of root? What is the meaning of root, beta? Very good. Very good. Very good. So many members are answering. Okay. So dekh beta, what is going to happen in this case? You have to, so many members have answered. Very good, very good, very good, very good, very good. Okay, now see here, what is the meaning of root? I have already told you, either you write root x or power 1 by 2, both having same meaning. Either you write root x or you write 1 by 2, both having same meaning, right? Whenever I'm solving these kind of question, I should know what is the power of x. What is the power of x? So here, what is the power of x, beta? 1 by 2. In future, right now I'm taking so much time to explain it, because yes, it is beginning. In beginning, sometime you don't remember the previous things. So for root x, I can write x power 1 by 2. So what is the power here, beta? 1 by 2. What will happen to the power? It will come forward. power will come forward, 1 by 2 will come forward, and into x power 1 by 2 you have to subtract from here 1. You have to subtract from here 1. The moment you have subtracted 1 from here, what answer you will get? Tell me beta, 1 by 2 minus 1. What is the answer you will get? 1 by 2 x power, what is the answer? 1 by 2 minus 1. Cross multiplication to 1 minus 2. 1 minus 2 minus 1. Minus 1 divided by 2. This is your answer. This is your answer. Or if anybody having beta power minus 1, for example, let's see here. If I'm writing x power minus 1. If I'm writing x power minus 1, I can write it to be 1 by x. I can write it to be 1 by x. In similar manner, if I am having x power minus 1 by 2, I can also write it 1 upon x power 1 by 2. So it will become 1 upon root of x. So I can write it in this manner. See, negative, so negative will come down, and if power is 1 by 2, you can write root here. So that is why what you will get here. To this, by modifying, what can I write? Or what can I write beta? What can I write? I can bring this to the down, and I can write its answer 1 upon 2 root of x. I hope this is clear to everyone. Very good. Are you guys understanding this or not? Only one formula is there. What is the main formula beta I am having? This. X power n. Power is bringing forward and subtracting minus 1 from here. Very good. So this is how you have to do the, I will ask more problems based on it. Very good. Very good. So next you will be having what? I will ask one more question from here. Sixth, tell me the differentiation of beta. Okay, I don't know whether you guys will able to answer it or not. 1 by root x. Tell me the differentiation of d by dx upon 1 by root x. Tell me beta. Will you guys get this, able to solve this, its answer or not? Tell me its answer beta. D upon dx into 1 by root x. Tell me its answer. What will be its answer? Will you guys able to solve it or not? Very good. Minus 1 by 2 x power 1 by 2 x power minus 3 by 2 x power 1 by 2 2 root x. No, minus 1 by 2 x minus 1 by 2 x power minus 3 by 2 minus 1 by 2 x x power minus 3 by 2. Very good, very good, very good, very good, very good, very good. So many members are doing very good. That means you guys have understood this. Now it is a good question. Here student gets stuck. It is a good question. So what I'm going to do here? My formula tells me when I am in this form, x power n. Is this is in x n power form? No, sir. So you have to make it. You have to make it. How will you make that beta? You have to write it like this. Since what is the meaning of root? Root meaning power 1 by 2. Root meaning power 1 by 2. But it is in the denominator. And my question and my formula tells me, give me the power to solve in the numerator. So I have to bring it to the numerator. So to bring it to the numerator, what do I have to do? I have to do its power will be what? What is its power beta? What is its power? When it will come up, so it will become negative. It will become negative. So I can write it minus 1 by 2. Now, if somebody is asking 1 by root x or somebody is asking d by dx x power minus 1 by 2. Somebody can ask, sir, how this minus 1 by 2 came? So for those guys, let me explain. I can do the reverse thing here. For example, if I'm having 1 by x this. So what can I write this? If I am having this x square, so what can I write it to? X minus 2. If I am having this 1 by root x, means 1 upon x power 1 by 2. For this, what can I write? X power minus 1 by 2. Right? Very good. So now here, let's solve it. Let's solve it. What answer I will get? What will happen to the power? What will happen to the power? Power will come forward. Very good. Minus 1 by 2, sir, came forward. What is the next step I have told you? From the power, how much I have to subtract? From the power, how much I have to subtract? Minus 1 by 2 and minus 1. So what is the answer beta I will get? Minus 1 by 2 into x. Minus, both having same sign. Negative and negative. So both will get added. Both will get added. Minus 1 and minus 1 by 2 and minus. So you can take minus common here like this, and inside what you get? 1 by 2 plus 1. What is the sum of 1 by 2 plus 1? Its answer will be minus 1 by 2 x power, negative sign is there, minus 3 by 2. Beta, why I am explaining this in so deep? Because these small questions that I have discussed, it will be get utilized in some cases, right? So that is why basics are very important. Like in vectors, I have told you basic, angle, wangle, like those kind of things. So that is why here, whatever the basic question that I am discussing today, these questions again will get utilized in the another classes. Right? Fine. Shall I ask one more? Shall I ask one more? Okay, fine. The next question that I am going to ask from you guys, d by dx of 1 upon cube root of x. I hope everyone know about cube root. This time, if I'm writing here beta, this like this symbol, and here 3. Here I'm writing 3 and this is x. This is the meaning of cube root. Okay, before this, let me ask very simple. First, solve this cube root of x. First in the upper power. Tell me beta, cube root of x. What is the answer of cube root of x? Simple, I'm asking. I have changed the question in denominator, then I'll ask. First, solve this cube root of x. Tell me everyone, cube root of x, what is the answer? For cube root of x, very good, minus 1. Beta, I have changed the question. It is cube root, not in the denominator. It is already in the numerator. It is already in the numerator. One by 3 x power minus 1 by 2. Very good. So many members have answered correctly. It means you guys have understood it very well. Very good. So for this, what can I write? I can write it to be d by dx. X power, cube root means 1 divided by 3. Cube root means beta 1 divided by 3. This is the power. Now, what will I do to this power? I will bring this to the forward. I will bring this power to the forward. So it will become 1 by 3 x power 1 minus 1 by 3. Because, oh sorry, ulta kar diya. 1 by 3 minus 1. So from the power, I have to subtract 1, right? This is it, khatam. That much easy it was. 1 by 3 minus 1. Cross multiply, so this will become 3. 1 minus 3. Minus 2 and LCM was 3. This was the answer for cube root of x. Now next question, I hope you know what I am going to ask. The next question you will be having like this, d by dx of 1 upon, this time cube root is in the denominator. D by dx of cube root of x. Tell me answer of this. Everyone solve it. Tell me beta, very good, very good. Solve this, very good. Very good, very good. So many members have already solved it. Very good, very good, very good. So many members have given its answer correctly. So here what's going to happen, it is again not matching with my formula. So if it is not matching with my formula, I have to bring this to the numerator. So I will bring this to the numerator. I will bring this to the numerator. Right? So here when it will go up, now it is not cube, it is beta cube root. So that is why when it will go up, what it will become? It will become x power minus 1 divided by 3. X power minus 1 by 3. Now next step, throw the power to forward, minus 1 by 3 into x power minus 1 by 3 minus 1, right? So what is the answer of it you will get? Its answer will be minus 1 by 3 into x power, this will become minus 4 by 3. I hope this is clear to everyone. This is clear to everyone. Very good, very good. Shall I ask one more? Let's see. Now if you are able to solve these easy questions, you will able to solve these. Sorry, these difficult questions, if you are able to solve, you will be able to solve this very easy. One last this kind of question I will ask, d upon dx x cube. Tell me the answer of this. dx upon x x cube. So again, is it matching with my formula? Is it matching? No. So for that, what do I have to do? I have to bring it to the numerator. Bring it to numerator and tell me the answer. After that, minus 3x power minus 4. Minus 3x power minus 4. Very good. Everyone is answering correctly. Everyone is answering correctly. Very good. Clap for yourself. So you can write it like this, beta. Anytime when the problems in the denominator, you have to bring it to the numerator. You have to bring it to the numerator. So it will become x power minus 3. So what answer you will get from here? Minus 3 x power minus 3 minus 1. Minus 3 minus 1. You will get this answer minus 3 x power minus 4. I hope this is clear to everyone. I hope this is clear to everyone. So now one variety of questions we have solved, which is totally based upon x, right? When x power is there, right? Now the next variety of question will be having something like this. This is the one variety of questions. Now if here after this is the basic question, next some basic question will be there, and then there is a combination of these formulas into plus, minus, multiplication. Then you will feel that the level has little bit raised. Might be you guys have felt here it was easy. When these things will get combined, it will again become lengthier, right? So let me tell you one more thing. Here, if somebody will ask you d by dx of, let's say, some constant is there. Now, what is constant? If some constant is there, is there any x in the bracket, beta? Is there any x is there in the bracket? Sir, you will say no, sir, there will be no x in the bracket. If there will be no bracket and if it is a constant value, can I change the constant? For example, if I'm writing 5. For example, if I'm writing 5, can I change the value of 5? But if I'm writing x, what are the possible values of x can have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, infinite. So that is why we call this as variable and we call this as constant. So when somebody has written that if you are trying to find the differentiation of constant, its answer comes out to be 0. This is the rule that you have to remember. We are playing a game in which we have to remember the rules. If we don't remember the rules, we will not able to solve the questions. Okay. So I hope everyone understood here. If we are having constant in the bracket, only single constant, then answer will become 0. So for example, if somebody is asking differentiation of this x with respect to 5, differentiation of with x with respect to 10, 12, answer will always be 0, these constants. I hope this is also clear to everyone. Okay, so next we'll be having when this differentiation is involved with some constant here and this constant get multiplied with x power n. If this constant multiply by x power n, so what will happen? Very simple. Constant, it is a 5. Let's say if I'm having this equation 5a plus 10b. Let's say beta I am having this equation 5a plus 10b. What is the thing here common? Or let's say here I'll write 5a plus 5b. So I will take 5 common because 5 not going to impact a and b. A plus b. So in similar manner in differentiation, the constant, now some student can get confused, sir, its answer will also be 0. No beta, its answer will not be 0. Answer will be 0 when only single constant is there. When only single constant is there, but when you are having constant multiplied by variable, constant can't do anything now. So that is why constant will come out of the bracket. So it will become constant out of the bracket into d by dx of x power n. D by dx power of n. This is how you solve these kind of questions. Now let me ask one question based on it. Very simple question I'm going to ask. So d by dx of I'm asking very simple question. 3x square. What will I do beta here? If I have written d by dx of 3x square, so what will happen to this constant? What will happen to this constant? Constant will come out. Lijiye sir, it came out. And inside what you left? D by dx of x square. D by dx of x square. What is the answer? What is the differentiation of beta x square? X square differentiation will be 2x. So what answer will you get? 3 into 2x. What is the answer you will get? 6x. So this is the difference between this rule. When very carefully see, everyone, I'm repeating once again, these are the basic question. Today's class is full of basic question which will be get clubbed. Next class will do the algebra. In algebra we will use addition, subtraction, multiplication, division. So that is why if only constant is there in the bracket, answer is 0. If constant and variable multiply, constant comes out. For example, 3x square. 3 came out. No change. When only constant and variable multiplied, it came out. Whose differentiation will be there? X square. Okay, beta, I will ask one more question based on it. Let's see. D by dx of 5x. Tell me the answer of this. D by dx of 5x. Tell me the answer of d by dx of 5x. हाँ बेटा, power should be, ले बेटा, power should be 2 minus 1 ना. Okay, ठीक है. So again I have written 1. Now I will not write it again and again. Very good, very good. 5. So many members are answering correctly. It means everyone have understood it. So what will happen? 5 will come out inside d by dx. Now if you notice here, dx and dx both are matching. So you can simply cut it, or you can also write it. 5 into power will come forward into x power will be what? 1 minus 1. So it will become 5 into x power 0. Everyone tell me. Remember this property in math, any number, x, y, z, whatever, power 0, answer will always be 1. Answer will always be 1. Any number raised to the power 0, give me answer 1. So that is why x power 0, answer will become 5 into 1, that is 5. I hope this is clear to everyone. I hope this is clear to everyone. Okay, next. I will ask very simple. d by dx of 7 upon 7x 3 by 2. Now this is how the questions will come. Ask beta. Tell me the answer. What will be the answer you will get here? 7x power 3 by 2. Time how much? Time is there beta. 5 minutes are there. Tell me the answer everyone. What will be the answer of this? Very good, very good. So what will happen? First, constant. Can't do anything. So it will become 7. Now beta, I will write this answer shortly. I will not write in long steps. I will not write it in long steps. So what is the differentiation? 7 is the constant, can't do anything. What is the differentiation of x power 3 by 2? What is the differentiation of x power 3 by 2? Everyone tell me. X power 3 by 2, 3 by 2 will come forward into x power how much? 3 by 2 minus 1. What is the answer you will get? 7 3s are 21 divided by 2 into x power 1 by 2. This is the answer you will get for it. Or you can also say 21 divided by 2 root of x. Very good. Shall I ask one more? Now today is not the time too much, so that I will ask the question from addition formation, and then multiplication, division. Those rules we will study in the next class. Until then, I will ask 1 or 2 more questions. Let's see whether you guys will be able to answer or not. Tell me the answer of this. 15 cube root of x square. Somebody was asking. Tell the answer of this. d by dx of 15 cube root of x square. Tell me the answer of this. What will be the answer? Tell me the answer. Tell me the answer beta. What will be the answer of this you will get? Anybody got this question answer? Anybody got this question answer? Anyone got this question answer? So here is the 15. What will happen to 15? 15 will come outside. 15 will come outside. Now, differentiation of whom? Differentiation of whom? It will go up. X square. Now here cube root is there. What is the meaning of cube root? Power is first negative sign will be there, because if you want to take this x upward, you have to use the negative sign, right? Then next step, cube root. What is the meaning of cube root? It means divided by 3, and square is also there. So this you can write. Now its differentiation. This is the way of writing it. Tell me the differentiation of this. So its differentiation will be what? 15 into, what will happen to the power beta? What should I do with the power? I should bring this to the forward. So it will become minus 2 divided by 3 into x power minus 2 by 3 minus 1. So what is the answer? 3, 5, and here you will get minus 10 x power, cross multiply, minus 3 minus 2. It will become minus 5 divided by 3. This is the answer of this question. I hope it is clear to everyone. So in today's class, what we have studied, the formula of x power n, and we have seen the cases of x power n. Then we have seen the constant. Then we have seen the multiplication of constant into variable. This is very important. Sometimes student get confused beta here. Again I am repeating, don't confuse between constant and constant into variable, right? So that is why be careful. If you are having any doubt, just watch the video again, right? You can reverse, you can do each and everything, right? In next class, in tomorrow's class, what we're gonna do, we are going to do these kind of things. Let me show you the trailer what we are going to do tomorrow. Just let me, for example, if I'm having differentiation of a plus b, two variables are there, so what should I do? I have to write it like this: d upon dx of a plus d upon dx of b. Two functions this time I'm having, right? So then multiplication, then division, and this a and b could be like this. It could be like this: x cube plus x square. So that is why I have taught you x cube differentiation, x square differentiation, so that you guys can apply over here. So that is why, thank you very much. In today's class, only this much. See you in the tomorrow's class. Bye bye. Until then, have a chill at your home.